lesser exponent. So if we look at x to the fifth and negative 2x to the negative second power, obviously the lesser exponent is that negative 2. So that is what we're going to pull out as the common factor. Now, if you've never looked at factoring a GCF out this way, I think it helps particularly in this case. When you are factoring out the GCF, it's like you're dividing both terms, or however many terms you have, you're dividing by what you said is the greatest common factor. So now we apply our exponent rules. When we divide like bases, we subtract exponents. So 5 minus a negative 2 is going to give us a positive 7 exponent. And then, of course, we take that factor out of the second term, so we're just left with that coefficient of negative 2. But also remember that factoring should always be checked by multiplying it back out. So when you multiply right here, you add exponents. Negative 2 plus 7 is 5. So you're confirming that you did factor it out correctly. Just kind of a weird idea here with these negative exponents. Let's look at that next example. We have x squared times x squared plus 1 to the negative fifth minus x squared plus 1 to the negative 4. So it kind of looks like we've already factored something out here because we've got an x squared in front of a set of parentheses. But you need to focus on the fact that these are your two terms. X squared times x squared plus 1 to the negative fifth is the first term. X squared plus 1 to the negative fourth is the second term. So what do they have in common? Obviously that x squared plus 1 term, we take out the lesser exponent, so negative 5 is less than negative 4. It is more negative. So that is going to be our GCF here. X squared plus 1 to the negative fifth is the LCD, or not the LCD, the GCF. Too many acronyms. So when we pull that out of the first term, we're left with the x squared. We've got a minus. Okay, when we pull it out of the second term, again, it may be helpful to kind of write it this way, divided by x squared plus 1 to the negative fifth. Okay, we have the same base. It's a big base. It's more than just a single term, but we do have the same base, so we subtract exponents. Negative 4 minus negative 5 is actually negative 4 plus 5, so that's just x squared plus 1 to the first. Now, normally I would not write that power of 1. I am going to in this case, just so that when you look back at your notes, you see what happened there. And I'm also going to do it because we had a negative in front of this term, and this term has more than one term to it, so we need to apply that negative to be able to handle this correctly. So we do need to apply that negative in our parentheses here. So we get x squared minus x squared minus 1. So really those x squares cancel. And all we're left with is that negative 1. So we're going to just put it in the front of our parentheses here. Okay, that negative 1, we're multiplying by it. That's the only thing that we're left with. If we're multiplying by a constant, we put that constant in front. So that's what we're going to do in this case. So kind of weird how this one ended up simplifying, but that is how it works here. Any questions about those two cases? Okay, let's look at one more scenario here. Not only do we have a negative exponent, it's also a fractional exponent. Not only is it negative, it's also fractional. Now we will talk more about what this fractional exponent stands for later on, but right now we're just going to focus on the negative exponent part. So, similar to the problem we just did, this is our first term, this is our second term. Okay, what do they have in common? They've got that x minus 1 in common. One of them is raised to the positive 1/2, one of them is raised to the negative 1/2. So negative 1/2 is obviously our lesser exponent. Now, in this case, they don't, but if we had something in common with the 2 and the 5, you still factor that out, okay? So don't overlook if they have something else in common by just focusing on the negative exponent. So 2x squared 5, they didn't have anything in common, so x minus 1 to the negative 1/2 is our GCF here. So obviously the 2x squared is still there. When we are factoring this out, aka dividing, subtract those exponents. 1/2 minus a negative 1/2 is 1/2 plus 1/2, which is 1. So we've got x minus 1 to the first, similar to what happened in example B. And then for the second term, we've got that minus 5. We pulled out the factor of x minus 1 to the negative 1/2. So that is it right there. So we do have some simplifying that we can do inside of our parentheses here. Distribute the 2x squared. And we get 2x cubed minus 2x squared minus 5. No like terms to combine there. We did need to multiply it out just to make sure, but there's not. So we can just leave it as is. Nothing simplified like it did in the last problem.